These are notes for Algebra 2, Section 2.4, pages 98 through 101 in your textbook, and they have to deal with writing equations of lines. Now, the method that we use to write the equation of a line depends on the information that we're given. By that I mean, we might be given 2 points and told that these 2 points make a line, and we want to write the equation of that line. We might be told 1 point that's on the line, and we might be given the slope of the line and have to write the equation that way, or we might be given the slope of the line and then told some other piece of information, or we might be given a point on the line and given some other information. The first one we're going to look at is writing the equation of a line if we're given a slope m and a y-intercept b. If we're given the slope m and the y-intercept b, we want to use slope-intercept form. Now, slope-intercept form is here. It's the one we're probably most familiar with. It's y equals mx plus b. M, in this case, is our slope, whatever slope it is that we're given, and b is our y-intercept. So, other than that, we just have y and x. This y and this x are not going to change. They're going to stay y and x. All right, let's look at an example of how this might be used. We want to write the equation of a line with the slope of 3 over 4 and a y-intercept of -2. Since we're given the slope and we're given the y-intercept, we want to use slope-intercept form. Right, our slope m is 3 over 4, that's what we're told, and our y-intercept b is -2. So we've got our equation. We say, all right, y equals mx plus b using slope-intercept form, and we want to replace m with 3/4, and we want to replace b with -2. We rewrite our equation using those numbers. We've got 3/4 x, y equals 3/4 x minus 2. Notice that this plus b became -2 because plus -2 is the same thing as -2. That is our answer in this case. Slope-intercept form is probably the easiest form to use when you're given a graph of a line. For instance, this graph here, we want to write the equation of this line. Now, we are told from looking at the graph what the slope is and what the y-intercept is. For instance, if I wanted to find the y-intercept, that's pretty easy. It's given to us at 0, 1. That means it crosses the y-axis at 1, and b is 1. From there, we just need to figure out the slope. Figuring out the slope means basically what we're looking for are 2 points that where the line crosses the corner of a box. So, for instance, our y-intercept crosses at the corner of this box, and if we move down the line, we are not crossing at a corner here, or here, or here. We are crossing at a corner right here and this is the point 2, -2. So we're crossing at this point. All right. Now we have 2 points that we know, so we want to figure out the slope. Well, we count out how it changes the change in y over the change in x. Y is changing by moving downwards 3. That means our downward movement is -3. It's also moving to the right 2, which means our x movement is 2. We put these together as a fraction. We have -3 over 2. Now we have our slope. We have our y-intercept. We can write the equation of the line. Again, we have y equals mx plus b. We replace m with 3/4, and we replace b with 1. So we end up with y equals I said 3/4. This is negative 3 over 2. Negative 3 over 2x plus 1. And that is the solution to this equation. Well, it's the equation, rather. The solution to the equation is the line. I'm sorry about that. If you're given a slope and a point that is not the y-intercept, we want to use point-slope form. Now, point-slope form looks like this. It might be less familiar to you, but you might have also seen it in Algebra 1 or in geometry. Point-slope form gives us y minus y1 equals m times x minus x1 in parentheses. Now, the first y and the first x are going to stay y and x. The y1 and x1 are the points, the x and y points, are the x and y coordinates of a point that we're given. And m is our slope. Now, the goal of any equation that's written in point-slope form is to get the equation into slope-intercept form, which is y equals mx plus b. So this is our end goal, y equals mx plus b. So imagine we're writing the equation of a line that passes through the point 5, 4, and has a slope of negative 3. Well, we know the slope m is negative 3. We don't know the y-intercept. We're not told that. We're told a random point 5, 4 that it's also on the line. In order to find the solution, we use point-slope form. And that's y minus y1 equals m times x minus x1. Right. I define x1 as the x value of my point, and y1 as the y value of my point. M is, of course, negative 3, so I can plug all of my numbers in, and that is my next step. I want to substitute. So I substitute y minus y1 is 4, y minus 4 equals m is negative 3, times x minus x1, and x1 is 5. So I substitute it in, and I get y minus 4 equals negative 3 times x minus 5 in parentheses. My next step would be to distribute. I need to distribute the negative 3, so that's the next thing I'm going to do. I'm going to distribute negative 3 to both x and negative 5. So I have y minus 4, which didn't change. Negative 3 times x is negative 3x. Negative 3 times negative 5 is positive 15. Last step, the last thing that I want to do here is to solve for y. I need this y to be alone. My goal is to get this into y equals mx plus b form. That means y has to be by itself, so I need to add 4 to solve for y. When I do that, negative 4 and positive 4 cancel out, and I'm left with y. On the other side, I've got negative 3x. Doesn't change. 15 plus 4 is 19. So my equation for this line is y equals negative 3x plus 19. All right, if I'm given 2 points but no slope, in other words, I'm told that these 2 points pass through a line, or a line passes through these 2 points, the first thing I need to do is find the slope. I can't use point-slope form until I find the slope. Once I've found the slope, then I can use point-slope form, which is what I used in the last example. That's y minus y1 equals m times x minus x1. All right? That means that in this situation, we want to write the equation of a line that passes through the points 5, negative 2, and 2, 10. The first thing I need to do is use the slope formula, which tells me that m equals y2 minus y1 over x2 minus x1. This is the formula that we learned in section 2.2. I'm going to define my points. The points of the coordinate points of the first point 5, 2 are 5 and negative 2. So x1 is 5, y1 is negative 2. For my other point, 2 is x2 and 10 is y2. I've defined my points, so I plug them in. y2 is 10 minus y1 is negative 2. So 10 minus negative 2. x2 is 2, sorry. x2 is also 2. x1 is 5, so it's 2 minus 5. x2 minus x1. 10 minus negative 2 is the same thing as 10 plus 2, so I have 12. 2 minus 5 is the same thing as, or is negative 3. I need to simplify this fraction. I always should simplify every fraction. So 12 over negative 3 is the same thing as negative 4. Both of these are divisible by 3, so I get 12 divided by 3 is 4. 3 divided by 3 is negative 1, so it becomes negative 4. And that's my slope. I use my slope and I use my point because I already have a point. x1, y1 is 5, negative 2. So I use my point and I get point slope form, which says y minus y1 equals m times x minus x1. Now I use the information that I've gathered to solve this equation. y1 is negative 2, so I've got y minus negative 2 equals m is negative 4 times x minus x1 is 5. I need to distribute. That's my next step. On the other side, I'm going to go ahead and change y minus negative 2 to y plus 2 just to make life a little bit easier. On the other side, negative 4 times x is negative 4x. Negative 4 times negative 5 is positive 20. My next step is to solve for y. So I subtract 2 from both sides. That leaves y on the left. Negative 4x plus 20 minus 2 is plus 18. So my equation is y equals negative 4x plus 18. Okay, I want you to write the equation of the line that passes through the points 4, negative 2, and 7, 4. When you've gotten an answer, you can unpause the video and we'll see how you did. Okay, so what I've done here is I was given 2 points on a line but no slope, so my first job was to find the slope of the line, and I did. I used the slope formula. I have 4 minus negative 2 is 6. 7 minus 4 is 3. 6 over 3 is 2. I use my point x1, y1, and I use my slope 2. Plug them into my equation, my point slope form. Y minus negative 2 became y plus 2. And then I had 2 times x is 2x. 2 times negative 4 is negative 8. I had to solve for y, so I subtracted 2 on both sides, and I ended up with y equals 2x minus 10. All right, the last situation that we might run into is one where we're given a different kind of information. In this case, for instance, we're not told what the slope is, but we are told that it's parallel to the line y equals 3x minus 1. Well, we should know from one of the earlier sections that if two slopes are parallel, that means the slope of the first line, m1, is exactly equal to the slope of the second line, m2. That means that the slope of 3x minus 1, 3, has to be equal to the slope of our new line. So since the first slope was 3, our slope is also going to be 3. So in a way, we were told the slope of the line. We were just given it as a puzzle we had to figure out. We were given the point 4, negative 2, so we have x1 and y1, which means we are ready for point slope form. So point slope form says y minus y1 equals m times x minus x1. Same old formula. We plug in our values, the substitute step. We have y minus negative 2 equals 3, our slope, times x minus 4. We distribute. I change these. I get y plus 2 equals 3 times x is 3x. 3 times negative 4 is negative 12. I need to subtract 2 from both sides to get y by itself. Now I have y by itself. I have 3x. Negative 12 minus 2 is negative 14. So my equation is y equals 3x minus 14. And you'll see that the slope of our new line is exactly the same as the slope of the line we're given, but the y-intercepts are different. That means that these two lines are parallel. We might be told that the two lines are perpendicular, which means that they cross at 90-degree angles. If two lines are perpendicular, that means that their slopes are opposite reciprocals. So we have the slope of one line. To find the slope of the other, we take the reciprocal and we change the sign. What that means for us is that we still have the slope of 3. We want to find the opposite reciprocal, so we flip 3 over 1 and we get 1/3. We change positive 1/3 to negative 1/3, and that is the slope of our line. Once we've got the slope of our line, we can use point slope form. Y minus y1 equals m times x minus x1. I substitute in my values. I have x1 and y1. So I've got y minus negative 2 equals negative 1/3 times x minus 4. My next step would be to distribute, and I'm also going to change y minus negative 2 to y plus 2. Now when I distribute, I know I'm distributing a fraction, but I treat it the same way I treat every number. I still distribute to x, so I have negative 1/3 x. Now I've got negative 1/3 times negative 4. That, when I multiply together, gives me positive 4/3. I could change this to a decimal, but I don't really want to because it would be a repeating decimal, and that's just too difficult to work with. So I'm going to leave it as 4 over 3. And I'm going to leave the slope as negative 1/3. I need to solve for y, so I subtract 2. Y equals, I have negative 1/3 x, hasn't changed. 4 over 3 minus 2, if I plugged it in the calculator, would give me negative 2/3. And again, I could change that to a decimal, but I don't want to. I'm going to leave negative 2/3 as negative 2/3. Means my equation is y equals negative 1/3 x minus 2/3.